mtoni. Makona yao hapa chini inaitwa, they call it Dandora but iko Ruai. Hiyo ya Ruai. Hiyo ndio another one in Kariobangi. Yes, sasa hiyo ni yao. Hiyo sasa ni ya Nairobi. My siwa is strictly for Ruiru and Juja. Although kuna overlap ka Githurai, unajua before devolution Githurai was Nairobi. Technically Nairobi. So once devolution came, part of it ikaingia Nairobi, part of it ikaingia Kiambu County now Ruiru. So that is why kuna part of it nafaa ni take over. Hata hiyo maji take over juzi tu. So this is stage number 1, inlet works, and even before that, wapatia small break before that. Have you ever thought what happens ukiwa ukinawa, let's say ama umetumia washroom ama release maji, what happens to it? Umeshafikiria beyond kutoka kwa hiyo the bottle trap and hapo nje? Now, how sewer works, once the water, you have utilized the water, umetupatia, and most of the water, I usually tell this, 80% of all the water in your house is wastewater. Itakuwa wastewater at some point, one or another. You hardly ever consume. So either umeshower, you have used the washroom, umefua nguo, umeosha nyumba, hiyo maji yote, most of it comes back to me as waste now. So out of all the water you consume, 80%, even that's our formula for charging for sewer. Now it is collected through lateral or reticulation system. Reticulation system basically means a series of pipes from wewe to mimi. So unlike stima itapita juu, sasa for me lazima ipitie through pipes ni collect. So from your house you go to a sublateral. This ranges from very small pipes, maybe from 100 mm, that is 4 inch, or 160 kama ni flat, but that also can be used as a sublateral. Sasa from the outside the plot. So whatever utafanya plumbing yako unitolee waste. Whether if it's a small household, a 4 inch will suffice. If it's a big maybe household flat, they use maybe 6 inch or 8 inch. 6 inch is sufficient enough. If you're using proper sewer, kuna gorofa unaweza tengeneza ina require more than 6 inch if you do the design. But for people just to be sure, they go kuna wengine wanapadaga wameenda overkill kidogo wameweka hata as high as 12 inch. That is foot moja, but nonetheless it is for your own good. Ikishatoka nje, now that is where it feeds into the sublaterals. We usually use manholes, and a manhole is an example. For ground staka hivi. But it's a ring. Unaona behind you, unaona ile ring. That's a manhole. So we excavate, we put the pipe, naeka hiyo ring sasa. You can either do in situ, uikoroge kwa ground, ama ufanye precast kama hizi. These ones are if you are doing very long distances, this one are the most effective because you just cast them, then you deliver to site. So you can actually cover many kilometers in a day. But the in situ one is the most efficient, inakuanga at least even watertight, but it takes a while. Cast moja takes around close to a week. Do preparation a day, maybe casting another day, curing another day. So at most, if you are very efficient, 3 days, just one manhole. Whereas these ones you can do 10 in a day. Chini kuchimba, set the pipe, backfill, put the manhole. Do the benching and the length. So once the sewer is collected, from the laterals in a feed, from the sublateral in a feed into a lateral. Now lateral is a collection. Think about plot zimegawanishwa. So hiyo sublateral ndio inachukua those effects, hizo plot zenu. They feed into the lateral now. Hii lateral ni imeshikanisha, let's say hiyo kote yote. That whole shamba yote si imekuja. Inafidiwa to what we call the trunk sewer. Trunk sewer sasa ni yenye iko kwa mto. And for lateral we move from BN 200 to BN 400 based on the catchment. So ile iko na flat, you can tend to do a bigger lateral because at a very small area the volumes are quite high. But if you do for very small areas, we can do even as small as 200. That is pipe 8 inch. Itabeba hiyo nini. It is based on the volume, the discharge unatoa, and the catchment. So then we get to the laterals, the trunk sewer. Trunk sewer now, many laterals combine to form a trunk sewer, or rather to feed into a trunk sewer. Now the trunk sewer ranges from DN 350, that is pipe 350 mm, to DN 750. 750 I think ni around 50 inches or thereabout. Whatever imenifikia hapa nayo is around 750 mm. So hii ndio inanifikia ikiwa hapo hivi. Collect the sewer. So you can imagine now the network from Githurai to Ruiru to everywhere. Ina collect hivyo tu. Pipes kidogo zinashikana zina feed into another bigger pipe. That bigger pipe feeds into another bigger pipe all the way to here now. Ikifika hapa hivi, there's just pali mmepiga kona hivi okay enough. There are some box culverts. Hata mkitoka mtaziona. That is where the sewer ina merge. We have for the Ruiru system we have two trunk sewers. We have moja inaitwa Kamiti, moja inaitwa Ruiru. Kamiti ni venye mmekuja. From hapo when you exit the highway kuingia, that's Kamiti now. Inakuja imepita hadi hapa hivi. So imefeed hivyo. Once it gets here, this is where we start the treatment. This is a full biological plant. That means hakuna chemical tutatumia, hakuna any mechanical device tutatumia. We leverage biology kabisa. And you shall see how and why we do that. Once it gets here, this is now stage 1. For biological system, it has 4 major stages. Stage 1, we call it the inlet works or the screening. Stage 2, we have anaerobic ponds. Stage 3, we have aerobic, the opposite of stage 2 now. That is stage 3, aerobic. And now the final stage, stage 4, we have maturation. Is what tutaona. So coming to stage 1 now. Stage 1, maji imeingia venye mnasikia ikiflow. Collect kwa manyumba nini imenifikia hapa. So with sewer is constituted about 10% solids, 90% liquid. So is all. And then the 10% you have the inorganic and the organic. Among that 10% of the solids. So you have in totality it's 100%. Then 10% of that is solids, 90% liquid. What I'm interested in is 10% or whatever it is in. Deal 9. Because water is water. Si ni safi. Imagine the same one. Unaona nimeitoa Karimeno, which is a dam, right? Nafaa nimeitumia, nafaa nirudisha kwa ecosystem yake iflow tu. Watu huko chini Ukambani na Mombasa watumie sasa. So I cannot say so I must away. Maji ina shida. So what you are removing is the impurities. Impurities ni juu zimepitia kwa hali, so people wameweka hizo impurities. That is what I am dealing with. Now, the first step we deal with the non-biodegradable, the screening. We screen makaratasi, diapers, hizo vitu zote. You'll be surprised what sewer can bring hapa hivi. Medical waste, bandages, nini, hizo takataka zote ndio we screen from here. The non-biodegradable ones. With vijiti, miti, plastics, hizo tu hizi whatever ukiona lita pahali. There are some areas, especially the low income areas, utapata mtu hawezi lipa garbage. So ukimwekea manhole hapo, the manhole becomes the dustbin yake. Kimaliza, fungua, nirushie. So hiyo uchafu yote nayo ikishanifikia, sina njia ya kujua hii ni ya nani nimrudishie. So unaona sasa I just have to deal with it. So I screen the non-biodegradable plastics, makaratasi na itoa vijiti. There are 2 sorts of screens. They have the core screens, although hii mvua ilikuwa a bit heavy kaiharibu kidogo, but mtaiona tu. Then we have the finer screens. The core screens iko na spacing ya around 75 mm. 75 mm ni kitu yote kaa kiatuka iwezi pita. But kuna very small particles zinaweza pita. Let's say to plastics udogo nini zote pita. So hizo zinatolewa in the finer screens. Finer screens we have spacing ya 25 mm. Basically 1 inch. This is space between kidole yako. Hiyo ndio spacing between the bars. So that is when the finer screens inatolewa. The finer than biodegradable material inatolewa. Now we go to the step number 3, or rather the hapo hivyo stage ya 3 hapo hivyo, whereby we measure the flow. Remember I mentioned we have a capacity of, you can remember, 5,000. That is what I'm receiving at the moment, but my capacity is 10,500. But currently dry weather flow is 5,000. So that's now I go to how to measure it now. Unaweza imagine a flow. So one would ask how unajua je imagine mingi na kidogo. So whatever unasikia hapa utaiona, it's continuous flowing. Now I go for the measurement. I have a flow measurement device known as partial flume. The partial flume now, sasa hapo ndio, it's a open flow measurement device for civil engineers. It is kama maji na flow ama mto na nini, it is very accurate to that degree. Unajua hii maji yasiyo huwezi eka meter. For fresh water they use meter because ni safi, inaweza enclose, alafu inatumia pipe system, so that is enclosed systems. For mine to ni open, I cannot use a meter to kipita hizo grades uchafu zitachafua. So that's why I'm not able to use a normal mechanical meter kama venye mmeona Karimeno. So for us now we use a partial flume. Partial flume ni device imekuwa tu constriction kidogo, then iko na vertical axis. The vertical axis is a graduated ruler too, ama an axis which has various measurements. So hiyo reading unachukua, una convert to a corresponding chart, inakupatia how much volume you're getting in an hour. Of course, ukipata in an hour, you can either work backwards, upate to even per second, per minute. You can know how much water is flowing, or you can upscale it to even per day. So that is what we do. We get per hour. So we take the readings every 2 hours. That is at 8, 10, noon, 2 p.m., 4 p.m. Because that is the period yenye tuko kazi. We work 8 to 5. So at 5 o'clock, those readings we convert them to a 24-hour period. We get the flow for a whole day. Yeah. So from here now, the water gets to the E stage hapa hivi. This is called a flow distribution box. Unaona the various, hizi vitu zinaitangwa penstocks. Penstocks basically ni gates. Inafunguka tu hivi, inafungika. Hapa hivi kuna pipes. Each pipe is corresponding to a specific series. So we have series 1, series 2, series 3 and series 4. Series ni just a couple of bonds zenye zinafanya the same thing. So for one series, I mean it has an anaerobic bond, iko na an aerobic na iko na maturation yake. So hii series iko nayo, hii series iko nayo, hii series iko nayo. So siwa ikiingia hivi, it's like its own train on sewer plant. You can easily extract this one and yeke it's a complete sewer plant. So inagawanishwa hivyo. Currently I'm only using 2 series, series 1 and 2. You see, for another thing about the design capacity of biological plants, the flow is very important to us. See, one would argue, mbona unapima hata flow yako? Sisi hiyo imekuja. Usafishe tu. With bacteria, with biology, you'll realize we leverage bacteria. As utaona hapo hivi, you'll realize as to why its flow, ikifluctuate kidogo, I must know and make some adjustments hapa na pale. So the water is fed into each series. So for now, ni hizi series mbili zenye unaona zimefunguka. This other one is called a bypass. Bypass, I mentioned dry weather flow. Dry weather flow means kama saa ya kujanyesha in a while, well at least for Ruiru. Sijui ka Rift Valley kunanyesha. But for us, it has not rained in the last maybe 1 month or so. So meaning sewer yetu ime subside. My sewer is not watertight, meaning even how Kenya is designed, ideally for tena urudisha nyuma kidogo, sewer kuna mara mbili. You can have a combined system whereby you take in storm water plus wastewater, or we have a pure wastewater kama hii. Nairobi is the only, Kenya too I think ni Nairobi too, and it is due to the capital city. Ukienda Nairobi haunagi open drains, ndio zimefunikwa zote. So unlike Ruiru tena unapata tumeweka mtaro inabeba hiyo storm water. So Nairobi, if you realize, it's very enclosed, and this happens for many cities. due to limitation ya space na hata security ya the population, they enclose all their drainages. So si maji yao yote ya stormwater kukinyesha inaingianga kwa sewer system. So it's combined, that's why it's called combined. For me, I have a pure sewer system, staki hiyo wastewater. Stormwater. So when it rains na nini, we bring your maji directly to somewhere else, Ponto or where. But it eventually gets to one or another. Due to the fact that some people sewer ilikuja after wamejenga. That means you are not able to drain vizuri, drain maji na venye barabara za siku hizi kama mwanamwaganga, si unaona venye wewe ongeza hardcore. Ukiongeza hardcore na umejenga, nyumba yako unajua utabomoa uinue tena. See, it's fixed. That level is fixed. So barabara ikiinuka, what happens to the storm water yenye iko huku kwako? Hakuna pahali itaenda because hii barabara ndio imewekwa drain na inakatwa mtaro vizuri sana, but you are lower than you have no way of kuweka. Then mimi nimekuja nimesema acha nikuwe mzuri, nimekuwekea wastewater hapo, nimekuwekea network very deep, nimekuwekea manhole. Ukinyesha watu niwekee yote hapo, inanyesha. And some people there is only so much they can do. Hakuna kitu unaweza fanya. Hata ukienda kwako kujaribu kumadvise as an engineer, hakuna kitu unaweza fanya. Simply mwambie ni sawa tu nipatie, wenyewe hakuna otherwise. Ni serikali yetu. You settle too early. But see, for people mwenye anajenga, we advise them to separate the two. Kama ni gutters, if you are not harvesting the rainwater, put gutters directly to the storm drain. Nje ya barabara yako iende kwenye itaenda. That one is allowed even by county, hiyo hawezi kukataza. Kumenyesha, sio umeleta mvua, si maji yako, hii itaenda kwenye itaenda. So for me, that's why nasema dry weather flow, I usually get some storm water kwa system. So the 5,000 yenye tulieka, juu kumenyesha si ita increase. But it is not sewer. Haina kitu yote, si ni maji tu ya mvua imenyesha tu imeingia kwa system yangu. And the kind of pipes we use PCC, precast concrete. Precast concrete ni, I wish we had a pipe here ni wa demonstrate here. Inakanga spingot. Hata pipe za PVC unaonanga venye inakuanga na kichwa pahali. Sort of the same, whereby zinaingiana. Sasa now it's a shorter pipe inaingiana. Each joint now it's not necessarily watertight. No, for PVC they put rubber, unaweza eka tangent. You told me you have plumbing students here. Yes, tangents ina seal kabisa hiyo inakuwa watertight. Yes. So for concrete it can wear out kidogo juu siwe ni corrosive. So unapata kama hiyo area ni mashi itaingiza maji. So when it rains, I get a spike in storm water. That means my flow comes from 5,000 to even a higher amount. Now, since that water is not sewer, I am not treating it. Sina haja ya kuitreat because there's nothing to treat. That's why I have the bypass. And since I have no way of knowing how much volume, ni last year kulinyesha sana. Yes, last year April, the long rains, that is March to May. You remember country mzima ilikuwa tu in havoc. Hata sisi wenyewe hapa Thika Road, there's a week we were unable to, even for me, I was unable to access this place for 3 days in a row. Your bridge ilikuwa submerged kabisa. And this other side. So either uko hapa ni ukae hapa, huko the other side ungeweza kufika huko for at least 3 days. Hiyo maji yote ina up kwa sewer. So what I do once it gets here, unai bypass. Since hakuna tuna treat, you just drain it, inaenda hadi kwa mto. Hivyo. Yes, it is mixed pamoja, but you see, if you mix the 5,000 and at times I receive even as high as 22,000. Like the last rain, my highest flow was around 54,000. Plant yangu jo ni 10,500. I'm receiving 5 times whatever I'm supposed to receive. So naona kuna venye I have not increased that many people. Watu wajajenga within 1 month ati wamekuwa wengi hivyo. And then even if ni hivyo, you have not increased your waste production by that much. If you shower once, uta shower 5 times, ukue nguo 5 times, ufanye nini 5 times so that for me to receive 5 times the volume, right? So that can only be explained by the storm water. So hiyo ndio maji, we bypass it, inaenda, we release it back to the river. The quality hata inakuanga more or less whatever is in the river. At times I have a better quality than whatever is in the river. Ujue yangu ndakam ni rake, nitoa hizo makaratasi na nini, lakini ile ya mto sinabeba uchafu yote. But for me mine at least nimesafisha. So in essence I usually have a cleaner sample than the river when it's raining heavily. Nakuanga hata nasaidia mto kidogo for the people who are downstream. So that is it for stage 1. So ikitoka hapa inagawanishwa inaingia now stage 2. So what you're going to do, utaona to appreciate hapa, then we'll move now to stage 2. You can ask any question at any time. Kama kuna any clarification, it can be given. Another thing, once imekuja hapa, in terms of quality, we measure the quality, we check the quality here. Kenye imeingia, there are a few parameters. Utaona pale kwa lab, we have a wastewater lab here. We measure some few qualities. One of the most important ni BOD, COD, and we have suspended solids and color. So that is just to get an idea of the water. Some other elements, the physical parameters, the chemical constituents of it, that is whether it's on elements, that is phosphates, nitrates, or they are done but on a weekly, because catchment it will change sana. So we don't necessarily do them. But whatever can change in a daily ni flow rate, and then those things, color na nini, based on maybe utafa hiyo siku ni much more turbid. Color is the same as turbidity. Umeona kule Karimeno, I believe you heard something about turbidity, how they measure the thing. So for me it's the same thing, but for me I call it color. For fresh water we call it turbidity, but it's the same thing. Yeah. So we'll explain as to why those parameters are important. So for now tutaona tu how it is flowing. Hii ingine, whatever you're looking at, this is an active site. There was an omission that was done when it was being constructed. We are supposed to have something called a drip chamber. Drip chamber, tumeona nimetoa the organics, nimetoa makaratasi na nini. But kuna another hiyo sealed, I'm unable to remove it using those clips. Unaona ni 25 mm. Hii mchanga yote si itapita. Yes. Then uwezi weka kichungi itakuwa kiblock. Ujue hii maji iko na some sludge nini. So a grit chamber, hii ndio inajengwa, it was omitted, but the contractor kawaida may demobilize. So it is almost being done. So hii inlet works ita move pale. So itakuwa at least now, maybe next time if you come, itakuwa imeshakuwa fully operational. Grit chamber basically inapunguza velocity. Velocity inafanya class 5 biology, decantation. Early primary, you can recall. Basically the same principle. Let the water settle, solids itaenda chini, then maji sitapita. Yes, that is what basically a grit chamber does. Si roxy science kubwa, najua it has fancy names nini. Najua zi engineers tunapenda kutishia watu sana with those fancy jargons na nini, but in essence ni hiyo tu. Maji settle, hii mchanga iende chini itoke. So hii mchanga is scoop it out or have a mechanism ya kui-flash out. Phase 2 we have one ukisha maji na reduce velocity, solids ina settle, ukisha settle maji inavuka. So I'm left with the solids sasa. So even your grit chamber ina work. For now iliomitio kidogo, but at least wanarekebisha. Yes. So tunaweza ona we can just